Okay, today's topic is Heisenberg uncertainty principle. Heisenberg uncertainty principle. Okay, what is the importance of Heisenberg uncertainty principle? Okay, this is very important concept, which is the one which proves Bohr model is wrong. Okay, then only this concept leads to the development of the quantum mechanics. Quantum mechanics is developed on basis of this. This one is the key point to develop the quantum mechanics. Okay, what is this theory? Okay, what it says. Okay, it states that it is impossible to determine simultaneously the exact position and exact momentum or velocity of an electron. This is the statement that he has given. He has given this type of statement. Okay, it states that it is impossible to determine simultaneously the exact position and exact momentum of an electron. Okay, if you see an atom, what it means, if you see an atom, the exact position and velocity determination simultaneously is not possible. Simultaneously, at a time, we cannot determine position and velocity of an electron in an atom. Okay, what he is saying, that one. Okay, we cannot determine at a particular time, as simultaneously means at that moment we cannot determine simultaneously exact position and exact momentum. Okay, why we cannot determine exact position and exact momentum or velocity of an electron? Okay, let us take an atom. Let us take some more example. Means atom. For example, you take an hydrogen atom. This is one electron. This is nucleus, and electron is revolving around this. Okay, circular orbit. Okay, this is n is equal to 1. Okay, yes, electron revolving around the nucleus. Okay, if you want to see the position of an electron, in an atom, you should use the light. You should use the light which is shorter wavelength than dimensions of the electron. Okay, diameter of the, let us take diameter of the electron has some value, and then if you are using the light to see the electron, that light wavelength should be less than this diameter. Then only you can see the electron. Okay, if you use such a low lambda value to see that electron, its momentum or velocity is drastically changes. Okay, if you see this one, then its velocity drastically changes, because if you want to see this one, you should use high energy light, because you cannot see the electron in an atom by using single light or small energy containing light. Okay, you should use high energy light, then you can see, but the velocity drastically changes, so you cannot determine the velocity of an electron. If you see it, you cannot determine the velocity of an electron. That is the reason why you cannot determine simultaneously the exact position and exact momentum of an electron. That is the reason why he has proposed this one. Okay, Next, what is this formula means? What is this formula? Del x into del px greater than or equal to h by 4 5. Greater than or equal to h by 4 5. Del x means is uncertainty in position. Del x means uncertainty in position. Del px means uncertainty in momentum. Uncertainty in momentum. Uncertainty in momentum. Okay. Then you may write another way also like this. Del x into p means p is equal to mv. Momentum is equal to m into v. Then del mv x. Okay. Then greater than equal to h by 4 5. Then you may write like this also. M. Okay. Mass does not changes. Mass, you cannot change the mass of electron, so velocity may changes. That is the reason why you can write like this. And h by 4 5. And again you may write like this. Del Vx equal to h by 4 5 m. H by 4 5 m. Okay. Del x into del Vx greater than or equal to h by 4 5 m. Okay. Then del Vx, okay, means del Vx is uncertainty in velocity. Uncertainty in velocity. What is the physical significances of this one? If del x value uncertainty in position low. If del x value is low, then what we understand from this one is you can determine a position of electron accurately. Okay, uncertainty is less means you can determine position of electron. Okay, position of electron is accurate. Okay, position of electron is accurate. Okay, is fixed or accurate. This means accurate. Okay, then if del x is greater than, if del x is high value, then what happens? Means position of electron is uncertain. You cannot locate the electron. Okay, position has uncertain, not accurate, not fixed. Okay, position of electron not accurate. That is the reason. Same concept here also, this here also. Okay, if del Vx is low value, then what we understand is del Vx velocity is low value. Then velocity uncertainty in velocity is low. Then velocity is fixed. Velocity has accurate. Okay, velocity is accurate. Okay, if del Vx is high value, velocity is not accurate. We cannot say what is the velocity means. Okay, uncertainty, it means uncertainty is low. we can determine velocity. Okay, high uncertainty is high, you cannot predict one. Okay, that is the reason why you can understand not accurate. Not accurate. This is the way you can understand this concept, and let us look into two problems. Based on that you can understand more clearly what is the Heisenberg principle, how it can deals. Okay. Let us see this. The effect of Heisenberg uncertainty principle is significant only for motion of microscopic objects and negligible for macroscopic objects. Okay, this Heisenberg principle, this one is valid for microscopic objects only, but not macroscopic objects, they say. How can we prove that? How can we prove that it is valid for Heisenberg principle is valid for microscopic but not macroscopic particles? Let us take two more examples for this. Okay, uncertainty principle is applied for milligrams, means 10 to the power of minus 6 kg mass of objects. Okay, this is greater mass than compared to the electron mass. So for this milligrams mass, then they are applied for the Heisenberg principle for that mass of the objects. Then if they find that they substituted H value 6.626 into 10 to the power of minus 34 joule second. 4 into 5 value is, this one is 3.1416 into mass. Mass of object is 10 to the power of minus 6 kg. They substituted and they get 10 to the power of minus 28 meter square second inverse. The product of these uncertainties is, the value is insignificant. There is no significant value. This is very low. You can, from this low value, this is very nearly to zero. Why they were not considered this is insignificant? Because 10 to the power of minus 28 is almost equal to 0. So where is uncertainty? Del V and del X. How can you calculate? If you want this one, how can you calculate by this one? We cannot calculate. Okay, this is almost 0 and is insignificant. Okay, there is no significance. It's almost 0. Okay, this value is very 0.0000. What the man? This one is very negligible and significant. So there is no meaning for this one. So that is the reason why this principle, Heisenberg principle, is significant only for microscopic objects, not macroscopic. This one is macroscopic. So the value of product of these two is almost 0.0010 to the power of minus 28 means 0.000 something. Okay, its value is insignificant. Let us focus this one. Uncertainty principle applied for electron whose mass is 9.11 into 10 to the power of minus 34 kg. Then what happens? Del V into del X is equal to H by 4 phi m. H by 4 phi m. H value 6.626 into 10 to the power of minus 34. Okay, minus 34 H value minus 34. Here is also 34. Okay, joule second. Okay, joule second. And for this phi value is 3.1416 in mass of the electron. Mass of the electron is this one, 9.11 into 10 to the power of minus 34 kg. So then they get the value 10 to the power of minus 4, which is significant value. Then compared to this one, it is 10 to the minus 20. This is significant value. Then del b del x is equal to 10 to the power of minus 4. Okay. If it has some value, then you can calculate this value. Okay. If del x is, okay, if del b is 10 to the power of minus 8, for example, means uncertainty is very low. And if you treat it as uncertainty in velocity is low, okay, uncertainty in velocity is low, 10 to the power of minus 8, the low value. Okay, uncertainty del b value is 10 to the power of minus 8 means it's low value, means uncertainty is lesser, means velocity is fixed somewhat. There is no uncertainty in velocity. Then we take it here, then what we get? Okay, del x is equal to this one undergoes this one, okay, by 10 to the power of minus 8 we can get minus 4 into 10 to the power of 8 means 10 to the power of 4. What happens? Means uncertainty in position is changes drastically. Uncertainty in velocity is low, then uncertainty in position is very high. So this is the way they said. This is the way they said this one is applicable for microscopic objects. Microscopic objects, we know we cannot determine this one and this one simultaneously. Okay, velocity and momentum, velocity and position cannot be determined simultaneously. Okay, this is the true. Okay, if uncertainty is very low, okay, velocity is accurate, then position value it changes drastically. Its value is very high, 10 to the power of 4 means very high. Okay, uncertainty in position is very high. Okay, in this way you can understand this one, this concept. Okay, is introduced by Heisenberg. Heisenberg got the Nobel Prize because of this concept. Okay, because of this concept, he questioned his teacher. Teacher means Einstein. Einstein student is Heisenberg. Okay, on that time he questioned, Heisenberg questioned his teacher Einstein. Then Einstein is not agree with his principle, because if his principle is correct, Heisenberg is correct, then Bohr theory does not exist. That is the reason why he cannot consider Heisenberg uncertainty principle, because the whole Bohr theory will not have the significance. Okay, according to Bohr theory, we know we can determine position and velocity. There are different equations are present in Bohr theory. Okay, but here we cannot determine position and velocity simultaneously. So whenever this Heisenberg uncertainty principle come into the light, then Bohr theory significance has lost. Okay, according to Bohr theory, we can determine position and velocity. There is some equations to determine velocity and position. According to him, we cannot determine simultaneously position and velocity. If it is fixed, it will changes. It will changes, it will fixed. Okay, uncertainty is here larger, then here it is low. That is the reason why uncertainties will changes for smaller particles. So according to him, according to Heisenberg uncertainty principle, Bohr model fails. Okay, there is some loopholes are found by the Heisenberg uncertainty principle. Okay, he is the student of Einstein. He questioned the Einstein on this theory. Okay, he introduced this theory. He was the one introduced this theory, and based on this, he questioned the Einstein. Okay, then he got the Nobel Prize, and then subsequently he is the one which is leads to the development of the quantum mechanics. He is the one which leads to the development of the quantum mechanics. Okay. Next, after some time, uncertainty term is replaced by probability terms. Probability. Okay, uncertainty term is replaced by probability. Electron is may probable here. Okay, which leads to the further development of the orbitals. Okay, which leads to the development of the orbitals. Okay.